Good morning everyone. Good morning all the students. How are you all? I'm also fine. This is Prema here. This is my channel SciMa Academy, and today I'll be starting up with the science chapter. Okay, so I'll be taking up the structure of atom, which is one of the most important chapters of grade 9 chemistry. And I found that from my students and other students, I found that this chapter is little tough for them. They are finding it little tough to understand. So that's why I chose this chapter to explain it to you. Okay, so take your notebook and your pen, and you can pause the video in between to take up the notes, because I'll be presenting the video, I'll be explaining at the same time. Simultaneously you will be taking up the notes also. This will help you in your exam preparations, okay, as exam is nearing, and you can make notes also out of it. Okay, so don't forget to subscribe to my channel, that is SciMa Academy. I'll be coming up with more videos in front of you. So let's start with the chapter. So students, the next topic is about the valency. Okay, so you have to study what is a valency, what is the meaning of valency, and how do we write, what is the method of writing the valency of any element. Okay, so this valency topic was there in your atoms and molecules chapter also, but you cannot understand that. You have to memorize there the valency, right? So here, if you understand what is the way we write valency, how can we say that the valency of this element is this? So there is a method to write, right? Okay, so we have to study that only. Okay, that's what I'm going to explain you here. So what is the meaning of valency? First you need to understand what is the meaning of valency. So valency is nothing but, valency is the combining capacity of an element. Okay, so just now which we have studied the EC, right? We have studied the EC. So if I say lithium atomic number 3, its EC was 2, 1. Okay, now the outermost shell, the outermost shell either has to be filled with 2 electrons, 2 electrons, that is a K shell. If the K shell is complete with 2 electrons, this will be called as duplet. Okay, or it is filled with 8 electrons. Outer shell is filled with 8 electrons. Okay, which will be called as octet. Okay, so atoms with completely filled outer shell, okay, whether it is filled with 2 electrons or it is filled with 8 electrons. If it is filled with 2 electrons, we call it as duplet, or if it is filled with 8 electrons, we call it as octet. Okay, that time we will say that the atom is stable. Atom is stable, right? That means its valency is 0. Why its valency is 0? Because it doesn't have to gain any electron, it doesn't have to lose electron, right? See, atoms are unstable, they have to attain stability, either they gain electron or they lose electron. Okay, so some atoms are filled, their outermost electron is filled, so they are already stable, they don't have to either lose electron or they don't have to gain electron, so their valency is said to be 0. Suppose if I give you an example, helium. Now helium atomic number is 2, so its EC will be what? Electronic configuration will be K shell filled with 2 electrons, right? So this is a very good example of duplet. So helium is having duplet configuration, where its outermost shell, here it is having only one shell which is filled with 2 electrons, right? So it is having duplet configuration, and so its valency will be 0. Valency is 0 and it is highly stable. It doesn't have to react to attain stability. Okay, it doesn't have to react to attain stability. It is happy with itself. It is not going to lose any electron. It is not going to gain also any electron. It is happy. Okay, it is stable, right? But if you see lithium, now lithium is 1 electron, only 1 electron in the last shell, right? Now if you see lithium, beryllium, boron, atomic number 3, 4, 5, EC2, 1, 2, 2, 2, 3, right? So here if you see here, the last shell is having 1, 2, 3 electrons. So when the elements are having outer shell electrons 1, 2 or 3, they always lose electrons. Okay, they will always lose electron to become what? To become like helium. So whenever an atom is losing or gaining electron, they want to attain the stable electronic configuration of the nearest noble gas. Now this helium is a noble gas. This is the first noble gas, okay, which is stable gas. It is also called as inert gas. Inert gas, or it is also called noble gas. Okay, now these three elements, lithium, beryllium, boron, they try to lose these 1, 2, 3 electrons in order to become like helium. They want to become stable. Nobody wants to be in an unstable state. They want to become stable. Okay, so now lithium, what will happen? Lithium is 2, 1. So it's easy to lose this electron, right? It's easy to lose this electron. Beryllium is 2, 2. It's easy to lose this electron. Now you will ask me that last shell can have 8 electrons also, that is octet. They can attain octet also. So but to attain octet, lithium requires how many electrons? It requires 7 more electrons, and beryllium will require 6 more electrons. That means they require more electrons, right? They are able to lose less electron. So here we have to talk about energy, no? Electronic energy. So here to lose 1 electron, here beryllium to lose 2 electron is much easier. Much less energy is required to lose 1 and 2 electron rather than gaining 7 electron here, gaining 6 electron here. Okay, so they will try to, so the atom always try to have a favorable condition, okay, where they are not losing much energy. So where they are not losing much energy, they will try to go with that path. Okay, so here it's easy to lose 1 electron, easy to lose 2 electron. Boron also easy to lose 3 electrons. Okay, it will not gain 5 electrons because lot of energy is required to gain 5 electrons rather than losing these 3 electrons. So it's easy to lose these 3 electrons rather than gaining 5 electrons to become octet. Okay, so here they lose 1 electron, to here 2 electron, and here 3 electron to become like nearest noble gas, that is helium configuration, that is duplet configuration. Okay, so here they will lose electrons, so they will have positive valency. So whenever an element is losing electron, they will have positive valency. So how much lithium is losing? Now lithium is losing how many electrons? 1 electron, right? So lithium valency will be 1 plus. So whenever element is losing electron, you have to put a charge of plus. Okay, and how many electrons it loses? 1 electron. So it will be 1 plus. Similarly beryllium loses 2 electrons, right? It will lose this 2 electron. So it will be 2 plus. And boron will lose how many electrons? 3 electrons. It will having 3 plus valency. Okay, so like that the valency will be how many electrons they lose to attain the nearest noble gas configuration. Okay, now if you see carbon atomic number is 6, its electronic configuration will be 2, 4. So in the carbon, see, there are exceptions where the outermost electron is 4, right? In carbon and in silicon also. Okay, carbon and silicon also. In elements like carbon and silicon is 2, 8, 4, 14 atomic number. Okay, so when the last shell is having 4 electrons, they will neither gain nor lose electrons. Okay, they will combine in a different way, forming different kind of a bond. When you go to higher class, you will study about it. Okay, so after carbon, if you see nitrogen, see nitrogen is 7, this is 8, 9, this is 10. So what is the EC here? 2, 5, this is 2, 6, this is 2, 7, this is 2, 8. Now if you see here the last shell is having 5 electron, here 6 electron, here 7 electron. But here this is neon noble gas, last shell is filled with 8 electron. It is complete, which shows it is octet. So this is stable. This is stable electronic configuration. It will not lose any electron, it will not gain any electron. Okay, so now when it comes to 5, so now nitrogen is having 5, so it will not lose this 5 electron, it will gain how many electrons? 3 electrons it will gain. Here it will gain, oxygen will gain 2 electrons. Here fluorine will gain 1 electron. Okay, because losing 5 electron, here losing 6 electron, here losing 7 electron will require a lot of energy, okay, which they don't want to lose so much energy. They will lose much lesser energy, okay. How they lose lesser energy? By just gaining 1 electron. Here by gaining 3 electrons. Here it has to gain only 2 electrons to become 8. Here fluorine has to gain only 1 electron to become 8, okay. So here, in order to not to lose much energy, here they gain electrons. So whenever the outer shell is having 5, 6 or 7 electrons, they always gain. So gaining electron will have negative valency. Okay. So when I say now nitrogen, so nitrogen valency will be N3 minus because it gained 3 electron. Oxygen valency will be 2 minus, it gained 2 electron. Now fluorine valency, it has gained 1 electron, so it will have valency 1 minus. So whenever an element is losing electron, see here, when they lose electron, they will have positive valency. How many electrons they lose, that much will be the valency with the positive sign, okay. When they gain electron, you have to write how many electrons they are gaining with the negative charge. So this is how we learn the valency here. This is how we can learn. When you know the electronic configuration, you are able to easily write the valency of that particular element, okay. So like that you can write the valency of other elements also. For sodium also we can write. See, sodium. So this is 281, 282, 283. See, now here they are having 1, 2, 3. So they will lose. So they will lose electron. Okay. So how many electrons it will lose? 1 electron. So sodium charge will be 1 plus. Here magnesium will lose 2 electrons. So magnesium charge will be, valency will be 2 plus, right? And aluminium will lose 3 electrons. So its valency will be 3 plus. So when you know the electronic configuration and you know how much electrons it has on the outermost shell. So if the outermost shell is having 1 or 2 or 3 electrons, they always lose. Okay. So which configuration it will attain to lose? It will attain nearest neon. It is like neon, right? Neon configuration is 2, 8. It will attain neon configuration to become stable. Okay, now here they are unstable because the outermost shell is not complete. When an atom is said to be stable, when their outermost shell is complete. But here outermost shell is incomplete because it is not filled with 8 electrons, right? It is not having either duplet or a octet configuration. So in order to become stable, they will try to lose or gain electrons, okay? So in silicon also, so silicon I already told you, it is 284. Okay, its valency will neither be negative nor positive. That is a different concept. Phosphorus 15, sulfur 16, chlorine 17, argon 18. So this is 285, this is 286, this is 287, right? And this is 288. Now this is also octet. This is stable because its outermost shell is complete with 8 electrons. So here it is having 5, phosphorus having 5, sulfur having 6 and chlorine having 7. So they will gain electrons. Okay, it's easy to gain here. How many electrons? 2 electrons it will gain. So it will become 2 minus. Sulfur will gain, phosphorus will gain 3 electrons to become 8, 3 minus. Sulfur will gain 2 electrons to become 2 minus. And chlorine will gain only 1 electron it has to gain. So it will become 1 minus. Okay. So this is how we write the valency of the elements. So first you should know how to write the electronic configuration, orbital structure. Okay. After that you will be able to write the valency. Okay. So if you don't know the atomic number, if you don't know the electronic configuration, you will not be able to figure out what will be the valency. Okay. So practice this. Okay. You can pause the video, you can go back to the videos and go back to the slides and you will understand. Okay. Slowly you sit around, say in your house during the weekends and try to write the atomic number, memorize the atomic number and try to write the EC and the valencies. Okay.